In this assignment, you're going to get some practice solving some circuits that have multiple resistors but are otherwise relatively simple. For this first one, the variables that we're given are voltage, and we're asked to figure out resistance and current. Voltage, resistance, and current are related with Ohm's law. And so we'd like to be able to just plug numbers in here, but we've got a problem. We've got more than one resistor. So what do we put in for our resistance? The 2 or the 5 or some combination? The answer is a combination. When they're in series, resistors are additive. So a 2 ohm resistor and a 5 ohm resistor, when wired together in series like they are here, will have an equivalent resistance of 5 plus 2, or 7 ohms. So the resistance total on the circuit is 7 ohms, and that is the number that we should use to calculate the total current flowing through the circuit. So if we know that the resistance is 7, the voltage here is 6, so 6 volts equals the current times our resistance, gives us a total of 6 divided by 7, or 0.857 amps. In this circuit below, we've got 4 resistors instead of 2, but the mechanics of the problem are really the same. You still have to take each of these individual resistors and add them together to get the total resistance. So 1 plus 12 plus 6 plus 2 gives us a total resistance of 21 ohms. And in fact, if you want, when circuits start to get bigger like this, you can redraw them with all of these resistors up top here replaced by a single 21 ohm resistor. They would be equivalent, these two circuits, if they were compared to each other for voltage and current. Now we're given in this example the current and not the voltage, so that's something that we're going to have to calculate. I'm going to start by putting in my total resistance, which I just calculated, is 21 ohms. Voltage by Ohm's law is still I times R. So since we're solving for V, we can take the current given to us, 2.2 amps, multiply it by the resistance we just calculated to get the total voltage on this circuit, 46.2 volts. Since we're trying to find also the power expressed on this circuit, we know resistance, voltage, and current, so we can use really any one of our power equations to solve this. But I'm just going to use what I think is the simplest one, which is power is current times the voltage. So the current of 2.2 times the voltage of 46.2 gives us a power on this circuit of 102 watts. With question 3, we have a similar setup. Multiple resistors, variables that we're familiar with, but now the wiring here is different. These are no longer wired in series. Each resistor has its own pathway, which means the resistance is calculated differently. So we have to take the reciprocals of each of these resistances and use that to find the total resistance. It looks sort of like this. 1 over the total resistance equals 1 over 2 plus 1 over 3 plus 1 over 4. The numbers on the bottom of this fraction come from each of these resistances provided. So you can add up those 3 numbers to find the reciprocal of the total resistance. You want to take 1/2 plus 1/3 plus 1/4 and then take the inverse of that result. That'll get you this number down here. The total resistance on this circuit is 0.923. If you want to add these up as fractions, you can find common denominators, use your fraction adding techniques, and then you would have to flip over the fraction to get RT, because this has got 1 over RT here on the left. But for most of you, it'll be easier to just put these into your calculator as fractions or decimals and then take the inverse. That's a really important last step, to take the inverse there. Now that we know the total resistance, since we also know the voltage, we can use Ohm's law to solve for the current. 12 volts equals the current times 0.923. So divide 12 by 0.923 and you'll get a current here of 13 amps. We're again left with a calculation for power that can be used as either a current and resistance, a current and voltage, or a voltage resistance calculation. Feel free to use whichever one you want in this case, but I'm just going to use again P equals I times V. It's the most straightforward way to calculate it, where the current is 13 and the voltage is 12. So that leaves us 156 watts of power expressed on this circuit. And then down here for number 4, similar setup as number 3. You've got 2 separate pathways, one for each resistor. So these are wired in parallel. So that means that we need to calculate the resistance with our fraction formula. 1 over 7 plus 1 over 3. And then to get RT on top of 1 instead of on the bottom of the fraction, you take the inverse of whatever that adds up to. The total resistance on this circuit is 2.1 ohms. Since we're given the power, this one sets up a little bit differently, but we have power of 42 and we have resistance of 2.1. If we want to solve for voltage with those variables, we need the equation P equals V squared over R, where we know that the power is 42, trying to find V, and the resistance is 2.1. So multiply both sides by 2.1 and then take the square root so that you're left with V here. So this would be times 2.1, that's now gone, square root of all that mess, gets rid of the squared here. So the voltage, when you solve for V here, is 9.4 volts. Now if you want to solve for the current, we have lots of options since we know power, resistance, and voltage, but I would settle in with Ohm's law, the classic representation of current, voltage, and resistance. We know our voltage now is 9.4. We're trying to find the current, and the resistance is 2.1 ohms. So if you divide 9.4 by 2.1, you'll get a current here of about 4.5 amps. So hopefully these problems make a little bit of sense to you now. You want to get comfortable solving these because the next step is to take elements of these parallel circuits and combine them with series circuits to get a little bit more complex, so we call it a combined circuit. If you're having trouble with any of these, make sure you get help before we go on to the next ones because they will be more difficult if you don't know how to do these.